Hello guys, welcome back to Maison African Motives, still on Mathematics Grade 12 revisions and working on derivatives. So we have got the question paper, which was actually from September 2020, Eastern Cape. So there are some questions that we need to focus on, revise, so that we understand how to apply those typical questions. So that's derivatives, differential calculus. So you're given 7.1, find the first derivative from the first principles if f of x is given as negative 2x squared. All right, so we are given f of x in this case as a negative 2x squared. First principles. All right, so okay, we can even try to work down this aside. I'm just gonna push this so that we can have our question here. All right, so that was 7.1, whereby our f of x is given as a negative 2x squared. All right, we actually know that if we are dealing with first principles, the formula is supposed to be the first derivative with respect to x is equal to the limit as h approaches to 0, where we have got f of x plus h minus f of x, like that, everything over h. All right, this is what you're supposed to have as from the formula of first principles. All right, if we are to check, we've got our f of x here. We do not have f of x plus h. So it can be wise that you just calculate your f of x plus h aside here, whereby you're simply substituting x plus h in place of x. So this will be negative 2 into x plus h, but don't forget to square that one. All right. So by squaring x plus h squared, we're going to have negative 2, which is x squared plus 2xh plus h squared from your identities. Or you can expand these brackets separately. If it is difficult for you, then expand the brackets separate. X plus h, you expand as usual. All right. So if you expand, this is what you're going to have. And there is a negative 2 that is going to multiply each and every term. So you can multiply by negative 2, which is negative 2x squared, negative times this, which is negative 4xh, negative 2 times h squared, which is negative 2h squared. All right, so this is our f of x plus h. So taking back into the formula, we shall have the first derivative with respect to x written as the limit h approaches to 0 of f of x plus h, which is negative 2x squared, negative 4xh, negative 2h squared, then minus f of x, of which our f of x is already having a minus. So it will be negative 2x squared, and a negative and a negative, that's a positive. So this will be a positive. All right, everything over h. You can see that the negative 2x squared and the positive 2x squared will cancel out. So which means we'll be left with this expression. The first derivative with respect to x is equivalent to limit as h approaches to 0 of negative 4xh, negative 2h squared, everything over h. All right, what we can see is that here h is common. So we can actually factor out the h, which is common here, so that this can enable us to divide the h, which is in the denominator here. All right, so you don't apply the limit whilst you still have the h in the denominator. Okay, so if we are to factor out the h out, we are going to have negative 4x here, and there are 2 of them on h squared. So if you factor out, you're going to be left with 1h there over h. So the h and the h can cancel out. That means we now have the first derivative with respect to x written in this manner, which is the limit as h approaches to 0 of negative 4x, negative 2h. We no longer have the h in the denominator. At this stage, that's where you apply the limits to say your h is now approaching to 0. All right, so if this h is approaching to 0, what does it mean? It means the first derivative with respect to x is just going to be left with negative 4x, because this is now a 0. So it will be negative 4x minus 0, which is negative 4x. All right, so that was the derivative, guys, from the first principles. As we can see, it actually requires you to be very, very sensitive on how to apply the formula and how to expand the brackets, and also the involvement of the negative sign whenever you are subtracting your f of x. Be careful with that negative that you be given. All right, on 7.2, we are now given to find the derivative of find dy dx if we are given 7x to the exponent of 4, this and that. Okay, so the first thing was to rearrange. Let's start from the square root of. The square root means to the exponent of half. So this was supposed to be written as 2 over x to the exponent of 3, then to the exponent of half. That's what we know about the square root. All right. Then the half and the 3 over 2 and the 3 will multiply so that it will be 3 over 2. So it will be x to the exponent of 3 over 2. Then from our laws of exponents, we know that if this number is in the denominator, for us to write it in the numerator on top, we introduce a negative in the exponent. So it will be 2x to the exponent of negative 3 over 2. All right, so this can be rewritten, guys. I'm just simplifying here. Our y can be written as y is equal to 7x to the exponent of 4, 7x to the exponent of 4 minus, here it will be 2x to the exponent of negative 3 over 2. So this is a new expression that you have that you are supposed to now differentiate with respect to x. That means you're supposed to drop the exponent as usual. That will be 7 times 4, which is 28, and we subtract 1 on the exponent. So if we subtract 1, this will be x to the exponent of 3. You do the same thing, you drop the exponent, you multiply these two. So that's negative 2 times negative 3 over 2. So as you can see, the 2 and the 2 cancel. So that means you'll be left with 3, because negative and negative cancel. So this will be positive 3. X to the exponent of, you subtract a 1 here. So it's negative 3 over 2, negative 1, of which from your calculator, this is supposed to give you negative 5 over 2. All right, so depending with the simplification, you can leave your answer like that because you're not told to leave your answer as positive exponents. So just leave your answer in this form is fine. All right, on 7.3, we are asked to find the derivative with respect to t of the following expression. So that's 7.3. dt of half gt squared minus 5 over t. Okay, 5 over t, just like what we did from the previous case, 5 over t is same as 5t to the exponent of negative 1 plus 3g. Okay, don't worry about the g. G is just like a constant. So g is a constant. All right, so if you are given derivatives, if they are adding or subtracting each other like this, you find the derivative of each term. So the derivative here with respect to t, you are focusing with t. So you're going to drop the exponent, which definitely is going to be half times 2, and that will be a 1. So here you'll be left with the gt. If we subtract 1 on the exponent, 2 minus 1, that's a 1, so it will be gt. All right, you do the same, we drop the exponent here, which is negative 1, so that means it's negative 5 times negative 1, which is a positive 5. T, then what happens? We subtract 1, so it will be negative 1, which is negative 2. Okay, 3g, it's a remember g is a constant, so there we are dealing with a constant throughout, so that means this gives us a 0 if we are to find the derivative. All right, so this is our derivative with respect to t. You can leave your answer like this, or you can even simplify this as gt plus 5 over t squared. Remember, to the exponent of a negative means 1 over that number to the exponent of a positive now. So that's what you can actually have at the end. So these are the typical questions, guys. As you can see, that's how they can ask these questions. And you have to be very, very careful when attempting such typical questions on derivatives. Yeah, I think it was clear. And even the marks here, we just said 12 marks, but these 12 marks, they are a lot of marks in exam. If you do not revise, they can tend to be a lot. But if you are revising, then it's fine with you. You know that you're going to collect those 12 marks if they can be any question which is similar to this one. So that's what we had, guys, for Meson African motives. Still on grade 12 mathematics, till we meet again. Okay.